In the last couple of years, a number of neurovascular companies have jumped on the clot aspiration bandwagon. And with that, we've seen a proliferation in aspiration pumps and the associated marketing that comes along with that. The purpose of this little garage science video is to try to clarify some of that. Specifically, I've been interested in seeing for myself which pump really applies more force to a clot and hence is more likely to hold onto or ingest a clot. This, of course, applies to adapt or trap techniques, where we are applying static force directly to a clot via an intermediate catheter. Now, if you happen to use the more traditional balloon guide and microcatheter only system, you have to think about things a little differently, and I'll come back to that at the end of the video. Okay, so in our lab, we use either the Penumbra engine or Stryker Medela pump. The first thing I wanted to see is the maximum static negative pressure generated by each pump. To measure this, we connected a pressure gauge directly to each canister without tubing, turned the pump on, and waited for the pressure to stabilize. With a perfect vacuum, you can theoretically achieve minus 29.9 inches of mercury. The Penumbra pump actually came pretty close to this, generating minus 29.7 inches of mercury. Now this is at the pump. My next question was, how much loss is there in the tubing? And if you think about it, as long as there's no flow and the tubing doesn't collapse, you should get the same thing. And here you see that's exactly what we got. In fact, the measurement came out slightly higher, almost minus 29.8, presumably due to some fluctuation within the pump. Bottom line though, in the static situation, the tubing really doesn't have any effect. So what about the Stryker pump? Without tubing, I got minus 24.9 inches of mercury. So 5 inches of mercury less negative pressure. A couple of things to note. Number one, yes, the pump was turned up to maximum. And two, I noticed that the negative pressure was actually initially much higher, i.e. more negative, when the pump was first turned on. But over the course of the next minute or two, it stabilized at this value. That was unexpected, so I didn't record it. And honestly, I'm not sure what it means at this point, and we might have to revisit this in the future. In any case, when we added the tubing in the static situation, as expected, there was really no change, still minus 24.9 inches of mercury. So there's a 5-inch of mercury difference in static pressure between the two pumps. But what does that mean in a practical sense? It's about a 16% difference in static force. But is that enough to make a noticeable difference when we're doing a case? To try to visualize this, I set up a tug-of-war between the two pumps. So what we have here is the Penumbra engine on the left connected through a valve to a length of tubing filled with water and some glass beads to help us visualize what's happening. And on the right, the Stryker Medela pump hooked up in a symmetric fashion. With the valves closed, we let both pumps stabilize, then opened them up simultaneously, and here's the result in real time. Okay, so what's the take-home message here? Well, at this point, I personally am convinced that for the purposes of direct aspiration or combined stent retriever / direct aspiration technique, using the Penumbra engine is going to increase my odds of holding onto that clot. But I don't think that's the end of the story. I didn't show it here, but most of you have probably already seen a demo with the larger caliber Stryker aspiration tubing, showing that you get much faster flow with the Stryker system. That's in the setting of free backflow of blood. So, as I alluded to earlier, if you prefer to work with a balloon guide and microcatheter only, then this may be preferable because in this situation, the purpose of the suction isn't to hold on to the clot, it's to clear any free-floating debris that might have broken off or escaped the stent retriever. In that situation, you probably want to have as much flow as possible, although there's a word of caution, the Stryker tubing by itself has a volume of about 75 cc, so that's something to keep in mind. Thanks for checking out the video. Would love to hear your comments.